Engineering is the bottleneck for human progress. While we can think and invent new knowledge and find better ways to collect, distribute, and analyze information, manufacturing is what allows us to increase our living standards. Challenges regarding scarcity and properties of input materials and design of end products have limited humanity so far in progressing much faster.
But 3D printing now stands at the dawn of a potential industrial revolution, allowing for rapid prototyping, high customization, and removing the barriers between production and consumption. Once the ways we make things change, the things we make change. Let's dive into that.
So welcome to the UTX podcast, episode number 7, 3D printing and additive manufacturing. UTX is your source of tomorrow's technology, presented by Techniax. I'm Valentin.
And I'm Ani. And today we're going to talk about 3D printing. We'll cover the most widely used 3D printing methods, including what input materials and printing techniques they use. We then move on to look at the present state of the industry, various players, and their exciting applications of 3D printing technologies. After that, we will explore the potential of 3D printing to change our society. After raising a word of caution regarding its challenges, we will top it off with our signature Utopian day in the life, our projection of how 3D printing will mold a very bright future. Let's dive into it.
So what is 3D printing? We are defining it as a type of additive manufacturing. So additive manufacturing is called additive because it adds layer on top of each other. So if you have a 3D printer, he prints out the object layer by layer. And he does that receiving printing instructions as computer-based visual models. A computer numerical control machining, or CNC, allows the computer to take control over the 3D printer, and the 3D printer will then execute the instructions given by the computer. The hardware can be anything from a simple household tool to a house or even parts for another 3D printer. So the things that the printer can print.
Now, as you mentioned, the 3D printer takes this computer-based visual model as the input design to then form and print the output product. And this model is often in the CAD format, something I'm sure you've heard of, and it stands for computer-aided design. And it's basically encoded in a three-dimensional geometric design format. Now, there are dozens, if not hundreds, of different additive manufacturing processes. We are discovering new ones every day, and these are applied to and interpreted as 3D printing. We will, however, focus on just the 3 most widely used techniques and present one example sub-technique for each technique. So the most common 3D printing technique is the so-called fused filament fabrication, FFF. So this method is the low-cost home-grade 3D printing, and it is used everywhere. It's mainly became very popular after its patent expired back in 2009. And the material that is used is a thermoplastic. Now, what makes a thermoplastic very useful is that it can be molded when it's applied, when heat is applied, and it can solidify when cooled. So this thermoplastic is used as the printing ink, so to speak. And it is fed as a thread or fiber-like filament from a spool into a heated moving printing head. And this head then applies heat and pressure to form the filaments, and this cools. And after it cools, you have a solid structure. This process is called extrusion. And the head that outputs the filament, outputs this filament then layer by layer, as we saw the additive aspect, and many layers form together to form this 3D printed object.
Another heavily used technique, I think the second or third most used in 2020, is sintering, or more specifically, selective laser sintering. In general, sintering is a technique that applies heat and pressure, but as opposed to the fused filament fabrication, the input material is nylon or polyamides. and they come in fine grains as a powder, essentially. So selective laser sintering is actually the second most used technique. And in this case, a laser is applied to produce the heat. It targets the material at predefined points. The points are predefined by a 3D model. And as the laser touches the material, so to speak, as the light touches the materials are then binded together and the solid structure is created.
Now, the third most used technique or model of 3D printing is very similar, but it is a more costly and high quality alternative, and it uses photopolymers as input materials. Now, special thing about photopolymers is when approached by light, in this specific case, it's a laser, it hardens the photopolymer. Now, this technique is known as stereolithography, and in this technique, the laser traverses a tank filled with the liquid plastic, and the path in which this laser travels is determined by the 3D model. Now, as the laser passes through the plastic, the parts that are touched by the laser now harden, and thus you create your desired structure. And when you compare this to the filament extrusion process, these polymerized products are more smooth and robust because of the chemical structures that are created by the laser.
And the fourth one that we're going to briefly explain is the multi-jet fusion. This is a relatively new technique, and it's applicable to build complex, lower-cost parts at higher speeds. The input material in use is nylon powder again. It works similarly to selective laser sintering, but it uses inkjets instead of lasers to form the material. The nylon powder, again, is placed inside a powder bed. The laser agents or the inkjets scan over the powder bed. They shape the powder and subsequently heat it with thermal energy layer by layer. One of the agents is a detailing agent. The other agent is a fusing agent. As the detailing agent holds the material together, so it sort of applies pressure to it, the fusing agent applies heat, in this case infrared light, and thus hardens the material. The detailing agent then the object is hardened by the detailing agent as it cools. So the detailing agent, after the heat was applied, cools the object. So how is this different from selective laser sintering? Now the multi-jet fusion method creates objects with finer resolution and smoother surfaces, as well as more consistent mechanical properties, more predictable and more robust properties.
So now that we've seen how 3D printers work and what methods are used, let's move the focus to the industry. So who are the players? What are why is the relevance, and what are the challenges? So talking about the industry size, the global 3D printing market was valued at around 10 to 15 billion US dollars back in 2019. And it's expected to grow with a CAGR of 10 to 15% until 2027. So estimations for market size vary between 25 to 45 billion US dollars.
So this is kind of exciting, and market growth is decent, but not as explosive as with other technologies that we've previously covered in this podcast. And one of the reasons for this might be that the consumer revolution of 3D printing, at least in the volumes, has not happened yet. So 77% of shipped printers in 2019 were for industrial use, so only one for consumer use. The total number of 3D printers shipped were 1.4 million in 2018. And by 2027, this number is expected to grow to 8 million printers shipped in a year. The main applications for 3D printing are in healthcare, the automotive industry, the aerospace or defense industry, and electronics, which we're all going to look at in more detail later.
Now to the players of the 3D printing markets, and of all the large manufacturers of classical printer devices, only Hewlett-Packard or HP is among the top 3D printing providers. And this is because of their printing legacy. And that's why they're also the biggest company in our lists of major players. HP actually developed the multi-jet fusion technology only in 2016, and by 2020 it was already the fourth most applied method in of 3D printing. Now they are moving things forward in general. They are using a open innovation approach. So back in 2017, they opened a state-of-the-art laboratory for 3D printing materials experimentation in the state of Oregon. And they later followed that up with a 3D printing center in the manufacturing metropole of Guangdong. However, despite all of this exciting innovation, they've only generated around $700,000 in 3D printer sales in the third quarter of 2020. And this is down from $1.1 million in the third quarter of 2019. So I'm sure some of it is due to the pandemic, but in general, this industry, as you mentioned before, is still very industrial, and we're still waiting for the consumer revolution to happen.
Yeah, so this business, it's not yet blockbuster size for HP. Let's look at more traditional 3D printing service providers and hardware manufacturers, which are not as known to the public. And we still want to show them to you because each of them has some interesting history that is relevant to 3D printing as a whole, or has some interesting applications that show us how 3D printing can be applied to the industry. The first one is 3D Systems, and they are in the 3D printing game since 1983. So the beginning 80s have seen a push for 3D printing, which we'll also see with the other companies. They have invented the mentioned stereolithography in 1989. So the third most used 3D printing technique in 2020 has been invented by 3D Systems. And ever since then, they have been pioneers in the industry, covering several patents, etc. Their 3D products and services cover almost the entire supply chain. So from 3D printers themselves and print materials to parts, services, and digital design tools. They provide their clients with the raw materials such as metal powder and plastic filament and the CNC machining. So that's what connects the computer to the printer. They manufacture both industrial or B2B application printers, but also B2C or so-called desktop printers.
Exactly. And speaking of stereolithography, another player that we have to mention is Proto Labs. They specialize in rapid prototyping. So they're the leader in moving a product from prototyping to low volume production. And they use not just stereolithography, but also selective laser sintering and direct metal laser sintering. Now, direct metal laser sintering, we did not mention because it is not as popular, but this technique prints on metals such as cobalt directly using a laser. As opposed to many other techniques, this one can be directly applied onto the metal material instead of relying on other polymers. And currently, their market cap is $2.9 billion.
So one of the bigger companies, another one of the bigger names in space is Materialize. And they are a Belgian company, being a pioneer and active in the industry since 25 years. They hold a 3-digit number of patents and have partnered with HP on the mentioned jet fusion technology, which is the fourth most used in 2020. They have also created prestigious partnership in the consumer space over the years, such as collaborations with Adidas or the Paris Fashion Week. Some of their first 3D printing activities have included anatomical models in both dental and hearing aid products. Next to their healthcare activities, they are also active in automotive, aerospace, art, and design industries, as well as eyewear products. They currently have a market cap of $1.2 billion, so also among the bigger ones.
Now, Stratasys, I hope I'm pronouncing it right, but Stratasys is another industry giant. And not only are they active since 1988, but the co-founder, Scott Crump, actually invented the fused filament fabrication, which, as we know, is the most commonly used 3D printing technology. He invented it back in the 80s. Stratasys operates primarily in the healthcare, aerospace, automotive, and education market. And to date, they hold over 600 granted or pending additive manufacturing patents. So a very defining giant for the entire industry indeed.
X1 also has created a new technology which is called the binder jetting technology. It's similar to HP's multi-jet fusion technology. They have done so in collaboration with MIT. And what binder jetting technology does is it uses a powder bed and printing agents. So instead of nylon, which was the case for multi-jet fusion, it uses powdered metal, sand, and or ceramics. Also, it uses a liquid binding agent to form the material instead of heat, so no laser applied here. The technology is well suited to print complex parts using or utilizing industrial grade materials.
Another startup that we've seen, and this is quite an influential startup, is Voxeljet, and they've been working very heavily on increasing speed of the sintering process. And shockingly, they are present in almost every industry where we can find 3D printers: automotive, the reverse engineering, aerospace, the heavy pumps industry, architecture, art, design, film, museums, and many, many more.
Wow, a lot of applications. Organovo instead is focused on healthcare specifically, and they create functional implantable human tissues for medical research purposes. They are using a 3D bioprinting technology, which more or less means in that case that they use actual human cells as printing ink. The cells are extracted from organs by performing a classical biopsy and then keeping the cells alive outside the human body using oxygen and other nutrients. The whole mixture is placed in a printer cartridge and structured using the patient's medical scans. The methods used for 3D printing of the cells are photolithography, magnetic 3D bioprinting, stereolithography, and direct cell extrusion.
Another startup is Nanodimension. Now, as their name states, they're focused on 3D electronics printing and nanotechnology-based ink products. And I quote directly, their flagship products include the Dragonfly 2020 3D printer, and where traditional 3D printers, you take weeks or months to print a high-resolution multi-layer circuit board, Dragonfly can do this in a few hours. And the applications of Nanodimensions technologies include sensors, antennas, magnets, and even molded interconnected devices.
The last example from our list is focused on 3D printing supporting processes. They are called FARO, and they do measurement, imaging, and visualization of 3D prints and objects that shall be 3D printed for manufacturing, engineering, and construction projects. They are active across a variety of industries, including manufacturing, construction, as mentioned, but also engineering and public safety. When we talk about public safety, an interesting case is that they provide 3D printing solutions for forensics. So, for instance, they are capturing a crime scene digitally in 3D.
Now, as we've seen from this very wide-ranging list of major players in this industry, we can see that the industry is still very dynamic and hasn't set in really. And this is due to the simple fact that applications for 3D printers are being discovered every day. And only once we fully extend the capabilities and discover the true potential of 3D printers can we see where all this technology fits in. Surprisingly, you'll notice that one major technological advancement or achievement that we reached last year by the Carnegie Mellon University was not mentioned here. We will get to that later in the applications, just a heads up. But now I think we can move on to the relevance. Why should we bother with
exactly
3D printing?
Now that we have a basic understanding of what 3D printing is and how the industry looks like, the question is, so what? So why is this exciting? And first of all, with 3D printing, we can really customize our prints. We can print complex and highly customized shapes that we can design on computers or later on even use AI or utilize AI to design those shapes, which are simply not possible to be made by hand. Also, it's relevant for rapid prototyping. It allows you to quickly build out a prototype for low cost and in quick time, and test the input materials and designs. This is really great for manufacturing. It's a major breakthrough because in manufacturing, obviously, you want to before you go and scale something, you want to test the materials and the whole process first.
Exactly, and furthermore, last year and probably a majority of this year as well, we have seen that due to circumstances like the pandemic, that economies can fall victim to complex global supply chain dependencies. And the ability to manufacture some parts on site in critical time would help alleviate some of that risk. And even the CEO of HP, Enrique Lores, has stated this.
What is really satisfying to me for these technologies is when they cut out the intermediaries. And 3D printing is one of those technologies that has the potential to cut out the intermediaries between production and consumption. The idea of locating the place of production at the customer is relevant, and it could also reduce the need for freight and logistics. It could thus also counter long-lasting trends as we know them, such as globalism or consumerism. But it could also turn out to be the opposite, because now that you can, or when you can print everything at home, consumption might also just rise. But more on that later.
Exactly. So that you mentioned consumerism. So in general, the idea that anyone can print, increasingly anything, anywhere for a much smaller cost is very interesting. And as more and more people get into 3D printing, we hope that some sort of crowdsourcing effect will come into force, where the distributed experimentation with input materials, designs, and maybe even printing techniques might accelerate the progress as we can tap into more and more people using it, and the benefits of 3D printer also increasing. And this might also allow for more and more goods to be economically printed by consumers in a very customizable fashion.
When we look at the ecological impact of 3D printing, there are three factors that are relevant. The first one is 3D printing uses less raw materials and subsequently less energy in the manufacturing process than reductive manufacturing. And the reason is that due to its additive property, you only use materials, you only print materials that are actually part of the final object. So nothing is cut, nothing is wasted, so to speak, at least in theory. The second relevant factor is that, as already mentioned, potentially the demand for logistics and freight might be reduced due to more localized supply chains, which obviously could reduce CO2 emissions as a whole. And the third factor is that 3D printing promotes the use of more lightweight alternatives. And as with the pioneership and the research into different 3D printing technologies, also the research into other 3D printing materials continues. So we can expect even more lightweight alternatives in the future. And this is relevant because lighter weight products potentially use less fuel. Think about a lighter weight car, for instance, that uses less fuel when being moved.
Yeah, in general, entire economies might be reshifted. We mentioned logistics, transportation, freights. These industries include, and manufacturing as well, of course, it could face vast unemployment if 3D printing brings the convenience of manufacturing anything at a very decentralized in a very decentralized manner. And this could maybe force entire countries to seek growth by use of digitization, maybe their IT human capital. And even more interestingly, we are still exploring 3D printing, but if we add another dimension, we arrive at 4D printing, which is a very young still, but emerging technology. And the extra dimension really means that these 4D printed objects now possess dynamic structures. So they can change in shape over time. They could maybe illuminate, maybe even self-repair, And we call this programmable matter because it is able to work with user inputs, and it can essentially react to information inflow, maybe, or even to changes in conditions such as energy inputs by heat or light. But I think programmable matter and 4D printing deserves its own UTX episode.
Looking at the applications, some of the properties of 3D printing allow us to do rapid prototyping, but we can also do industrial grade production quality. Another one is low volume production of specific or customized parts. So when you cannot immediately scale your production, when you need to test something, when you need to customize something, think for instance, if you want to customize the interior of a car, 3D printing has some obvious advantages in comparison to classical manufacturing.
Yeah, speaking of customizing parts, one area where 3D printing has a lot of potential to change the industry is healthcare. So 3D printing is increasingly being applied to produce medical items and even prosthetics. And these, of course, by their very nature, need to be highly customized. And this is already being applied to implants, dents, bones, you name it. And some of the very exciting applications in the recent past actually include the reconstruction of a face after a severe road accident, or a 3D printing-based kidney transplant that was done for a 3-year-old boy. But previously, we mentioned Carnegie Mellon University. And towards the end of last year, the Carnegie Mellon University actually achieved the first 3D printed human-sized heart, one that was functioning and is made of elastic materials. Now, this new 3D printing method which they used is a real game changer, and it is called freeform reversible embedding of suspended hydrogels, or FRESH. Now, this FRESH method basically prints little blobs of what they call alginate, which is a type of biomatter, and they print this into an existing hydrogel, and they let the materials bind together in this hydrogel and then wash away the hydrogel, thus leaving only the printed object as a remainder. And now, if you can print objects, organs that are very realistic, not only is this a great method of practice for upcoming surgeons, whether it's the heart, the brain, the liver, lungs, kidney, whatever, it also means that you could have transplants, not just heart transplants, but all types of organs. So this is a very exciting and promising area for 3D printing. Another one is the automotive industry. And nowadays, well, we know that cars have many different parts, but some of them can already be 3D printed today. And the ability for the manufacturing process to be customized or even personalized, be it interiors or extra accessories, are a great area for 3D printers to also join in. And even these manufacturing tools can be 3D printed. And we actually found some companies that have already presented visions for 3D printed cars. One of them, the most famous one, is the Divergent 3D Blade, which is a supercar that is supposedly able to reach 320 kilometers per hour or 200 miles an hour. And it is said to be made entirely from carbon fiber tubes and 3D printed aluminum rods. But they're not available as of now. So hopefully that comes in the near future. Another famous one is the EDAG Light Cocoon, and this was unveiled at the 2015 Geneva Motor Show and is set to be released in 2025. So it's just another 4 years before we can get a supercar that is 3D printed, and fingers crossed that it happens by 2025.
Wow, and now we're getting even more high-tech. As we've seen in our space colonization episode, and I really urge you to check that one out if you haven't yet, even full rockets can be built with 3D printing. In this case, the space logistics startup Relativity Space does that in their Stargate factory, and it takes them 2 months to build such a rocket. Now consider that a rocket is a very complex device. It has thousands, if not hundreds of thousands of parts. Relativity space has reduced the number of parts and has simplified the production process, and also made it with only 3D printers. Their printers use powerful robotic laser arms, and even NASA has also started to use 3D printers on their missions. So what they do is they allow their astronauts to print out small components on the fly in case they need something to fix something, hopefully something small, within the rocket. That's really useful because consider that astronauts can be on the fly for months or even years. Additionally, so in the future, if and when we will colonize Mars, and any production facility is far away, fresh supplies far away, everything needs to be stored and printed. And if you could print it, that could be useful, obviously. In May 2015 already, the Airbus has also announced that their Airbus A350 contained more than 1,000 3D printed parts. So aerospace in general is moving in that direction as well. Now, if you need new parts in a time-critical fashion, which not just astronauts do, but you also have that in remote areas or places where catastrophes have happened, then a 3D printer could also become very relevant. The application, the 3D printer has already been applied to humanitarian situations and the development sector. As an example, imagine being in a remote mountainous place and your water pipe breaks. So instead of waiting for days and weeks, which you would have previously had to do, considering that the water is dirty and you need to clean it first before you can consume it, you could print yourself a new water pipe within minutes, and also a robust one that doesn't break too soon again. Lastly, also in electronics, 3D printing makes its appearance, where 3D printing vastly simplifies the process for manufacturing circuit boards.
Now moving on to another application, which is arguably much larger than water pipes or electronics, is entire houses or major construction. So in 2018, a family in Nantes was the first to move into a 3D printed house with 4 bedrooms and around 1,000 square feet property. Now, the printing process took just a little over 2 days. However, the contractors had to take up 4 more months to add the windows, doors, and roof. But the input material was cement and polyurethane, and the cost savings were nevertheless about 20%. So while the printing process is quite fast, the contractors took very long to make it a functioning house and not just a 3D printed block of cement.
Further on, there is consumer goods. In consumer goods, there are 2 sub-industries that are very interesting, where we have foods and clothing or fashion. For foods, now consider some variety of foods that are appropriate candidates for this. We consider sweets, pastry, flat foods such as crackers or pasta. But also in 2018, the bioengineer Giuseppe Sconti developed a plant-based meat that he printed using a custom 3D bioprinter. Also excitingly, you can print stuff that looks different than it tastes or otherwise, which is also something that comes along with a 3D printer. So you could print something that looks like a chocolate but tastes completely differently. Another subsector is fashion and clothing. And the benefits for the manufacturing techniques here is that you can lower time and cost for customization. And also, obviously, as mentioned, in the future, we might be able to print our own clothes at home, which I consider an exciting imagination. So far, we've already have seen 3D printed bikinis, shoes, dresses, and even eyewear. For instance, Nike uses the 3D printing for both design and customization of shoes for their athletes.
And to cap off the applications, the last one is quite obvious in my opinion, education. So 3D printers in classrooms would allow not just children, but I think anyone to really experience and learn the properties of input materials, and hopefully also think like an engineer and in general make manufacturing and engineering appear more sexy in the future, just like machine learning has made statistics more exciting. Now, Elon Musk and many others have actually said that we have a global shortage of engineers and in general people that make stuff, to quote. And obviously, the quest for human progress can only be answered in the engineering space because you have to make those things first. You have to manufacture them. So hopefully 3D printers not just require more engineering and manufacturing talent, but they inspire and create more.
Yeah, let's look at some of the challenges that we face when we make stuff with 3D printers. And the first one is quality assurance and compliance to material standards. Because if now we can all print our stuff at home, if increasingly new printers and new printing techniques are applied, it's still relevant and a tough challenge to make sure that these still fulfill the quality that we need. And if you're talking about airplane parts, etc., obviously there is still the typical control mechanisms in place to secure that. But for other industries, there might be a gap there. Another key question is the recyclability of input materials. Because while 3D printers potentially use less input materials, the question is which these are. And if we look at advanced nanomaterials and powders, the question of whether they can be recycled or not is not fully solved because some of them can't. The granularity and customizability of 3D printing, however, allows for rapid experimentation with materials. Thus, we would probably see a lot of material innovation, as already mentioned, a lot of material innovation in the future, which then would counter such issues when it comes to recycling. So you would see more recyclable 3D printing input materials in the future.
Now, on an even larger scale, these issues become even more important because if the overall printing volume is higher than in a classical economy, given that anyone can have a 3D printer at home and they can constantly print out anything they desire, anything they fancy, this could cause excess waste, triggered by, of course, consumerism and private experimentation. So waste management, as you mentioned, and also recyclability might become an even bigger issue than they already are today.
What we see with the digitization or with the rising of the internet in terms of the media industry is the so-called filter bubble, which essentially means that we only consume what we want to see, what we already know. And this is sort of realized by the algorithms. For instance, if you search on Google, your search results will be different than mine, and you will be fed whatever you've been looking at Instagram. You will be fed in your timeline afterwards. The same thing could be applied with 3D printing. It could mean that fashion trends might be a thing of the past because everyone uses their own clothes and personalizes the way they dress and their fashion. It could also be, however, that this prevails in the 3D printing era because there is just, after all, a human tendency to follow the latest trend. And let's not forget that trends are also made by money. So someone has to invest a lot of money in order to create the hipster trend or create some other trend for those people then to feel like they are individuals and make their own decisions. So there might be an increased political polarization as well, because if you consider filter bubbles, that's all sort of, it's a bit, it leaves a bad feeling in your stomach. But when you know that this is also has an impact on political thinking and political decision making, then really becomes relevant, because you could argue that the divide that we've seen, for instance, between Democrats and Republicans in the US is also based on, and for sure it's based on what they see when they go check social media, which is what they've previously wanted to see. And the whole story with Cambridge Analytica is known to all of us, and thus it's really relevant that these filter bubbles could grow further when we look at 3D printing.
And yeah, speaking of a lot of money being invested, another challenge is the not definition, but probably redefinition of IP rights, intellectual property, and copyright laws for 3D printing designs. So as I mentioned before, chances are it's very likely that manufacturing designs will be more widely distributed into internet, and thus might not just become less protected but harder to protect. So this means that it might be harder to earn a profits by doing any manufacturing design. So maybe this changes the way that we perceive certain industries, certain sectors. Maybe this makes manufacturing less appealing. But what we know for sure is that the way the internet will yet again restructure entire industries.
So before 2009, the patent for the filament production technique has been held closed. After it has been publicized, the idea of 3D printing in the consumer space became something. And for anything that previously has been an industrial application and is then used by consumers, you need to think about health and safety issues. And in this case, we're talking about the use of chemicals and lasers, and these could cause severe injuries. Metal powders are also potentially subject to dust explosions, which anyone that uses in an industrial manufacturing space and has worked with such powders will be able to tell you. Also, there is the threat of inhalation of nanoparticles or skin exposure to those. So health and safety issues are also relevant for 3D printing challenges.
And now, finally, the last challenge is, again, a bit more legal one, if you will. So this one is basically the ability of anybody to manufacture not so desirable items themselves. We had a case back in 2015 already when an ambitious maker 3D printed a handheld railgun that was capable of firing aluminum or graphite projectiles at over 250 meters per second. That's more than 560 miles per hour. So the US Department of Homeland Security has already warned of a potential threat that will be caused by people who could print guns. And while prohibiting the practice doesn't solve the problem, it will be very difficult to enforce any prohibitions when we're talking about such a decentralized technology. But now that we've gotten a good look of all the challenges, the players, the applications, I think it's time to move on to our favorite segment.
The favorite segment is the Utopian day in the life with a 3D printer in a 3D printing world. So I wake up in the morning, as always, and I am testing my printed gadgets. I'm springing out of bed, running over there to see what my 3D printer has done overnight. And also I monitor the progress of my 3D printed car in my garage, which has specific interior which fulfills my personalized wishes. What we can see here is that we have agile and simplified supply chains. I basically just need some basic input materials, some plastics, some nano materials, some polymers and nylon in order to manufacture almost anything. And a lot of CO2 has been saved because the need for logistics is also reduced, and I can fully personalize all my consumption.
Exactly. So we wake up in the morning, we go to the office with our 3D printed car, and then for lunch, I feel like, all right, I'm going to head over to a restaurant. And now this, I hear, is one of the first restaurants that is in a completely 3D printed building. So not just the cement, but also the wiring, glass, etc. Everything was 3D printed in this building. And I've sent my dietary options, restrictions, and maybe even my needs via my BCI to the restaurant, and now the restaurant has printed a plant-based meat, 3D printed this meal, not just printing plant-based meat that looks and tastes exactly like meat, but because it is 3D printed, it also has many of the nutrients, vitamins, minerals, etc. All the important things that I need for my diet are also in there, and it tastes wonderful. It follows all my dietary restrictions, and I can enjoy it knowing that no animal has suffered for for my tasty meal.
Great. So very productive day I've had so far. Now I'm reading about a new design idea for a desk, and I'm currently redesigning my home office. So I decide to 3D print an improved version of that using fully recyclable materials. I then have a chat with a local engineer, colleague of mine, who is currently building medical surgery tools with 3D and even printing 3D based organs and prosthetics for real life uses. So I'm getting really excited by that.
And then in the evening, I decide to go out with my 3D printed bike. It's already been a few years, and now I was going up a hill, really pressing on it, and my pedal was broken. So what do now? I just took a picture of the bike. The AI analyzed it. Thank God it was just a way down back home. So I just used the brakes and got back home. But the picture I took was sent via my BCI straight back home to my computer. The AI analyzed it, prepared a CAD model, sent it to the CNC. And by the time I come back, there's a beautiful little customized pedal that is printed with instructions as to how to insert it back. This took about a minute of my actual efforts. And I'm done for the day. Oh, I almost forgot to take my 3D printed personalized dose of medicine. But my BCI automatically initiated the printing of these new doses. Just for I was on vacation recently and had a very wild diet. So I'm coming back, eating more healthy, taking my nutrients, taking my medicine.
Whew, that was somewhat exhausting, but now all the duty is done. And I'm feeling blessed because virtual reality is a thing in the meantime. And that's great because my gaming experience is very much enhanced, not just with virtual reality, but also I can utilize 4D printed objects for gaming. And they consist of programmable material. So I'm playing some kind of game and then my material lights up. It adjusts its temperature and shape depending on the game situation and also its texture. So I'm really having a fun night with colleagues.
And then I decide I'm a bit hungry. So I decide to maybe have a small snack, not shortly before going to bed. My BCI tells me that it takes at least 2 to 3 hours before bed. So I know that I should eat this healthy meal, but it's really healthy and I don't want to ruin my mood. So I, of course, have it 3D printed, but the 3D printer now has this new innovative technology that allows tasty food to be presented in a way that looks very tasty and is very tasty. In other words, it is printing it in such a way that I can enjoy a meal, but I also know that it's actually very healthy for me. I go to bed having given out my 3D printing orders for the next day. Whatever meal my BCI tells me and whatever I feel like having, we reach a decision. And I go to bed looking forward to the next day of the 3D printed world adventure.
Amazing. What I'm curious about is in this 3D printing future, what would happen to all the land and assets that previously have been used for manufacturing and retail or stores, because you won't need them anymore, wouldn't you? Or you could forgo many of them in this new world.
Exactly. We could potentially solve climate change not only by having more trees and more wildlife flourish. We could now also create 3D printed buildings that are very heat and energy efficient. Not only that, they have, due to being able printed from the ground up using special technologies, they can now maybe even include certain little machines that convert CO2 back into oxygen and use the stored carbon, storing it back into the ground. So really, 3D printing is, as we mentioned before, the market size. It's not a very sexy technology, but I think it's just because we don't know what all we could achieve with 3D printing if we reach that utopian day. So until then, I just hope that we keep pushing on this very exciting technology. I think nevertheless it can have a very big impact on not just the way we live, but also societies at large, countries at large, shifting our attention to maybe more meaningful industries, meaningful sectors, meaningful jobs, and not something like manufacturing. So who knows what the future will hold?
Yeah, if anyone from the future is listening to this, and I hope you enjoy it as much as we do imagining it.
And if you feel free to share in the comments or on our social media platform, maybe what application you would like 3D printing most. What would you print if you had a 3D printer right now? Do share that with us. And that's it for this week's episode. Next week, what do we have next week? I forget already.
I think it's IoT.
Exactly. Oh yeah, smart cities, IoT, and 5G. So that is another interesting one. I think that is one of the first technologies that are so close in grasp that we could be talking a matter of a few years to maybe a decade, depending on how fast we recover from this pandemic and can move forward. But it's definitely something interesting. Yeah, so please, if you enjoyed this episode, do like it, share it with your friends, subscribe for your source of tomorrow's technology weekly podcasts. We will be tinkering with a new format in February. But so far, we hope that you've had a good start into the new year and that you've been very optimistic about hopefully living in a utopia very soon. As always, stay utopian.
Your Techniax.